Hey YouTube, JP Dillon here. Today we're going to take a look at a Sherwood S-7200. This is a stereo receiver made about 1970-71. I believe it was 20 watts per channel. And its owner have given it to me to repair. It said it was playing merrily along, and then all of a sudden there was a horrible noise and now silence. And the machine comes on, but otherwise there's no sound. No sound at all. The tuner, if we go to the tuner, we can see that the needle over here does deflect when I tune, so that tends to suggest that the tuner portion's alive. But really what we need to figure out is what's going on to prevent it from running. Obviously there's a lamp out, but that's really not why it's here. So though we checked the obvious things already, the fuses are good. So now it's time to get inside of it and figure out what's going on. So let's get the cover off. Alright, so here it is with out of the case. This one doesn't look like it's ever been cracked open. It's pretty dirty on the inside. There's your bottom part. And so, just looking at it, this is your phono stage, input selector, switch matrix, main power supply capacitors, main preamp. You've got a big dropping resistor for something there. You've got your impedance protection resistors there. And up top, there's our primitive regulated power supply. Not much to it. That looks like your multiplexer. That's your FM. And that's your AM. That's your tuning condenser. And there's your driver boards. So what we're going to do is we're just going to grab a meter and a little clip lead here so I can, excuse me just a second, I'm going to put this down. We're going to clip on to ground, so we have a ground reference, which is almost always the chassis on these. And we're going to turn our meter on, turn the machine on, and we're going to start taking some measurements and seeing what's missing. Because obviously for it to light up and no sound, and to there not be any blowing of fuses or anything violent, that tends to suggest something in the regulated supply. But we'll check the amplifier. Got minus 35. And plus 35. So this is a full DC amp. Minus 35 there. Plus 35 there. And it looks like we've got biasing here. So, next thing we do, obviously, let's come back to make sure our speakers are on here, make sure there's no DC offset. And we'll see here at the speaker terminals, we have 0 volts, which is very good. We've got a small offset of 96 millivolts, but that's really not a big deal. So let's come over here to our regulated power supply. This is the input side. And then we have various outputs. Here's your B+, which again is 35, and B-, which is minus 35. And then we come over here. Here's a Zener diode that's supposed to set a reference voltage. That's your 11 volts there. And then we've got another regulator transistor here, which is probably the series pass for the tuner. We've got 33 volts on the emitter, 41 on the collector, and 34 on the base. And looking at the outputs here, regulated supply, we've got 33 volts. We've got 31 volts, 11 volts, that's your tuner, and 35 volts there. So in theory, this should be running, in theory. But it's obviously not. We don't have any sound. So the next thing we need to do is take a look and see if our preamp is getting voltage and if our preamp is alive. Because obviously I can come around here and let's see, we've got minus 1.1 there and minus 1 there. Okay, so it's not stuck in thermal protect mode. There are thermal sensors on this. It is somewhat of an intelligent machine. We have biasing on our Class AB drivers. You got 0.8 of a volt there. Let's see, you got minus 33, and then minus 1.1 there, minus 0.9 there. So amplifiers, this one's got a little bit hotter on it. Amplifiers are running. Okay, so let's quickly flip it over and let's see what's going on underneath. Have to do this one-handed, so I apologize if it looks a little quirky. And let's take some measurements here. This is our signal out. This is that. Okay, another signal out. And I'm poking around here. But so far, let's see here. Did my ground lead come off? Nope. Okay, so we are grounded. Let's just do a brief check here, anywhere on the board. Yep, so the meter's hooked up right. We are reading voltages. But so far, let's see. Okay, there we go. We've got 15 volts there on the collectors of those transistors. 3.8 and 3.3. We've got 13 volts there. And we got 10 there. That's a little low. Okay, and then just come on over here for no reason here. You get 2.7 there, 3.4 there, and 13 there. Okay, so the lower level stages are alive. It's very interesting. So why isn't this thing making any sound? Well, the next thing we're going to do is hook it up to a load and pipe a signal through it and see where the signal stops. So let's get to that. Alright, so I've got a signal piped into auxiliary. And as you can see, nothing's coming out but a hum. I'm going to try to turn the signal generator up. It just ain't nothing happening there. It's just a big fat hum. But here's the interesting thing. If I jostle the machine, it goes crazy. Really goes crazy. So I think obviously we've got a broken ground or a loose connection somewhere. The selector switch feeds power to various portions of the machine. Now we were getting, just switch to auxiliary here. Yeah, see, it's just intermittent noise and giant hum. I think somewhere we're losing ground. So let's take a look at that. Let's look at the selector switch, because that's pretty significant. See, if I put the selector switch in the right spot, it will give me signal, but I got to hold it in the right spot. And even then, it's still crummy. It's kind of a weird failure. Alright, so let's get the thing on its butt and let's take a look. Let's look at the selector switch here. Okay, at first glance, there's nothing too strange about this. They've got everything very tightly bundled, though. I'm not very thrilled about that, but sometimes companies just do that. But what I do notice here, as I move things around, see, I can press on some of these terminals and they're still fairly firm against the wafers here. They don't move very much. But some of them were quite loose. This one over here is very loose. And this one here, this green one here, we can see that that flexes quite a bit when you touch it. Also, the ground for the both the preamp and the phono boards go through a switch wafer here on the selector. This is the ground. At least that's what my meter tells me. That's ground. So when it's not in use, the phono preamp is not grounded, and the preamp is intermittently losing ground. So because there's not a sufficient ground here, we don't get very good signal because the voltages on the transistors are fluctuating. And since this is a simple capacitor coupled design, the voltage has to go through the selector board before it gets to the preamp, which I don't think is a very good idea, but nevertheless, that's just how they designed it. So I think what we need to do is hardwire this ground to the chassis so that it's always there rather than going through the selector switch, and then clean the piss out of the selector switch. Just as a preliminary test, I'm going to get a clip lead and clip it to that grounding point there on the selector matrix and ground it right to the chassis, and then we'll see if we get our signal back. Alright, so you can see I've got a jumper here from the ground, the body of the switch, to the ground point there. And now I have a signal. And when I switch from input to input, it's still kind of crummy, but I have both channels. This switch is the contacts on the switch are very corrupt. So that we need to clean that, and then I need to install a permanent ground for this selector switch. Why they ground it through a wafer, I'm not sure. Also, one other thing I notice here, if we go to FM, no, it's not doing it now. Maybe that's, there we go. We're losing one channel on FM, but I think that's a part of the selector switch problem. So let's get some deox on the selector switch and then see what happens. We're just going to do all the switches and controls while we're at it. So I'm just going to get in here, hose this guy down, and then we'll also do the selector switch here for the speakers. And then we'll get in here. Sorry if it's shaky. Come on, focus, focus. There we go. All right. Might as well do them all while you're in here. And then what we'll do is we'll work the piss out of it, clean the lens off since I got some back spray. This is about the worst I've ever seen a selector switch. Okay, so I still need to do the volume control, but look at that. And we got both channels back. Nice and clean and clear. Selector switch for the speakers is pretty touchy too. Let's see if we can get a little bit more on that. Interesting how that makes it behave. You got a dirty switch and you don't know what happens. It all depends on the design of the machine. Most machines, they would not... Oh, and by the way, I did clean the scope. This is after about another couple of weeks worth of use. My hands are just dirty. Before the video's done, we'll clean it again for them that are worried about cleanliness. Okay, so that looks a little better. Ooh, what's that? That's new. Do you see that? That little wave there bobbling up and down. I can't really hold the camera still long enough to get you to capture it, but see there? Let's see if that's volume independent. Let's crank up the sensitivity a little bit. Ah. New problem. Let's see if messing with the selector. Nope. Look at that. New problems, huh? Look at that. So that's a new issue there. So we need to figure out why that's happening. That's interesting. Interesting. Alright, well, we've solved one problem and discovered another. I can remove the jumper wire now, and the selector switch kind of works. This is interesting. Alright, so let's get this turned back over again. And my noise is gone. But when I press on the driver board, it certainly comes back. It's another loose connection, because if I move the set up and down, problem comes back. But now it's quiet again. Interesting. Oh, now it's back. Let's see if I press on the board. Yep, if I press on the board, it goes away. So there's something going on this driver board here. Loose connection of some kind. It's getting pissed off. We need to go through that. But we've solved one problem at least. And also we're getting bobble on both channels now, suggesting an instability in the power supply. Because it ain't supposed to bob like that. But yeah, if I just wrap anywhere on the machine, the vibration pisses off that right channel. It's definitely in the driver board. All I have to do is press on the driver board. So there you go. We've got some things fixed. So the selector problem is done. We got sound. But now I'm starting to see why this was really acting up. It's largely because of this problem in the other amplifier, which we need to take care of. So the next installment, we'll be working on the driver board. We're going to resolder the piss out of everything and then retest it. Because the longer it stays on, the hotter it gets. Let's see if I touch this Class A thing. Nope, that's not it. That's not it. I'm looking for a point of sensitivity by touching components. It could just be an overall crumminess, so we'll take care of that. Also, when we get the disabling failures fixed, the next thing is going to be checking all these capacitors. These purple Panasonics like to die. The gray Elnas are probably way past their prime. But it's good that there isn't any sort of horrific failure. We just need to take care of what's ailing the machine currently. So that will be the next installment. This is part 1. And, oh, I promised I would clean the scope. So we're going to clean the scope real quick, and then we'll close out the video. Alright, so the scope's cleaned up a little bit. Anyway, this was part 1. Next time we get into this, the next day or so, we'll tackle resoldering those boards, do some preliminary checks on capacitors and things, and then we'll go from there. And if there's time, then we'll take off the front panel, deal with the lamps, and then clean all of these front panel switches here, which we missed, which couldn't get to without taking the front panel off. Anyway, thanks for watching. More to come on this soon.